Hey everyone, today we're going to be talking about homework number 20, and this was out of section 11.5, which was dealing with a geometric series. So remember, series, it's just a list of numbers that has a bunch of addition signs in them, and we're talking about geometric, so we're multiplying by some constant term to get to each next successive term. Alright, so the first set of problems, you guys are doing 1, 2, 4, and 7, which just says, evaluate the finite series for the specified number of terms. So let's go ahead and do number 3. So in number 3, I gave you the series 3 plus 6 plus 12 plus ... and it says we're going to do that for 7 total terms. So if you remember from class, I gave you a shortcut for evaluating a finite series, and the shortcut looks like this. S sub n, some series, is going to be the first term, times the quantity 1 minus r to the nth power. Remember, r is just whatever your ratio is. If you're multiplying by 3, it's 3. If you're multiplying by 4, so on and so forth. And then we're all going to divide that by 1 minus r. So at this point, it's just plug and chug from here. So I know I'm looking for when n equals 7, and I know my first term is 3. So a sub 1 is 3, the first term. And here, for r, I figure out what I'm multiplying by. To get from 3 to 6, I'm going to multiply by 2, and 6 to 12 multiply by 2. So I know r is 2. This n up here is the n from here, which is just 7, and our denominator is just 1 minus 2, and I'm just going to go ahead and plug that in already and say, hey, that's negative 1. I'm just doing 1 minus 2 here, which is negative 1. Okay, once we clean this up a little bit, I'm going to make sure I follow the order of operations, and I'm going to do 2 to the 7th power. So I'll still have the 3 outside, I'll have 1 minus, and then for 2 to the 7th, I'll get 128. And that's all over negative 1. So now at this point, we just keep going with our order of operations. We stay inside with our parentheses, and this is going to look like 3 times negative 127. All over negative 1. Now I'm going to do 3 times 127, and that's going to get me 381. And then remember, we did positive times negative, so that's going to be negative 381 all over negative 1. Negative divided by a negative is a positive, and anything divided by 1 is just itself. So this series is going to evaluate to 381. Alright, for your second set of problems, you are doing 9, 11, 12, and 17. And the directions just say, decide whether each infinite geometric series diverges or converges. Remember, diverges means basically shoots off into infinity, and converges means it's going to go to some number, and it's going to actually have a sum. And then it says state whether each series has a sum. So if it's diverges, it's not going to have a sum. If it's converges, it is going to have a sum. So the nice thing about these problems is it's not actually asking to calculate the sum, it's just asking will it converge or will it diverge. So remember our rules for converging and diverging. So something will converge if the common ratio, or r, is less than 1. And remember, it's the absolute value. It can be negative, it can be positive, it's just got to be smaller than 1 or negative 1. And then it will diverge if that common ratio is anything else, really, if it's bigger than 1. So you guys were doing 9, 11, 12, and 17, so let's just go ahead and let's do 10. So in 10, I see that it's an alternating series. I see minus, then plus, then minus, so that tells me I'm going to have a negative r. And then the actual series itself is 1 minus 1/2 plus 1/4 minus ... And if we look to go from 1 to 1/2, Clearly I'm dividing by 2 or multiplying by 1/2, and then I divide by another 1/2. So my r, I know it's negative, so I'm going to say r is actually negative 1/2. Alright, so at this point all we're going to do is check to see if it converges or diverges. So I look and I see, hey, 1/2 is definitely smaller than 1, so I know, hey, we're up here. It converges. So to answer this one, I'm just going to say this converges, and if something converges, it will have a sum. It's not going to go to infinity or positive infinity, so I say yes, has a sum. We don't necessarily know what the sum is yet, but this question wasn't asking for that, so we're good with just saying it converges and has a sum. Alright, so that's a perfect segue into our next set of problems. So in the next set, you guys are doing 18, 19, and 21. And this problem set just says evaluate each infinite geometric series. So this is if our series converges like our last example does, it's going to have some sum. So now we're going to actually calculate the sum on these. So if you remember, one of the last things we did in class was I gave you an equation for evaluating an infinite series. And it's just going to be the first term, a sub 1, over 1 minus the common ratio. Pretty nice, simple equation to follow. So I'm going to go ahead and do 20. So question 20, I gave you the series that's 1 minus 1/5 plus 1 over 25 minus 1 over 125, and then plus dot dot dot. So it's really nice if you get a series that starts with 1, because it's going to show us what our ratio is really quickly. So clearly here I am multiplying by 1/5, because if I do 1 times anything, it's got to be itself. So I'm going to be multiplying by 1/5. And if I check that again, if I multiply 1/5 by 1/5, the top will stay the same because 1 times 1 is 1. And the bottom will be 5 times 5, and I get to 1/25. So that does work. That is our pattern. I'm multiplying by 1/5. So first of all, I know this series converges because 1/5 is less than 1. Second thing we check here, it's going negative, positive, negative, positive. So I know r is actually negative 1/5 for this one, and that's very important. Make sure you check to see if it's an alternating series or if it's just a positive series. So now all I gotta do is plug in. My series will be equal to the first term, which was just 1, all over 1 minus whatever r is, and r is negative 1/5 here. And I'm actually going to use negative 0.2. I just did 1 divided by 5, and I'll use the decimal form. Alright, so now to clean this thing up, a negative of a negative will become just one big plus sign. So this is just going to end up being 1 over 1.2. And then we just go ahead and do that division. And I'm going to get that this series converges to approximately 0.8. And you know what? We don't even have to use approximately. 3, and the 3 is repeated. And that is what our series converges to. Alright, the last set of problems says you guys are doing 25, 26, 28, and 29, and you should be pretty familiar with this problem set. It says determine whether each series is arithmetic or geometric, then evaluate the finite series. So remember, arithmetic, just abbreviate it like that, is for plus or minus. And then geometric is for multiplication, technically division as well, but we try to just hold it at this multiplication to figure out what our common ratio is. So once you've figured out if it is arithmetic or geometric, it then says to evaluate. So we've already done some work with the geometric, and we know that these are finite. So if it is geometric, we're going to use the following equation. S sub n is equal to a sub 1 minus r to the nth, all over 1 minus r. And on the other hand, if it is arithmetic, you're going to use the equation from last class, which would be S sub n equals n over 2, a sub 1, which is just the first term, plus a sub n, which would just be the last term of the series. So since we've done enough examples of both of these, I'm going to just call it good here. If you have any questions, please feel free to email me, and I will see you all in class.